Okay, you're writing this down. 5.8, get paper out. 5.8, graphing absolute value functions. Let's go, let's go. Notes out, writing it down. Let's go, let's go. In your notes, absolute value, graphing absolute value functions. You could cap your marker in between problems. That's helpful so they don't dry out. So in your notes, you're drawing the parent function. This is called the parent function, absolute value of x, because it starts at 0, 0. Parent function. It's written right here. If we subtract 2, like we did here, it just takes the absolute value function from 0, 0 and moves it down 2 spaces. Okay? Moves it down 2 spaces. So when the minus 2 is after the absolute value bars, like it is here, it moves it down 2 spaces. Okay, so give me those 2 graphs. Draw them in your notes. Always good to take notes in graph paper. So if you don't have a graph paper notebook yet, go buy one. I would always take math notes in graph paper, just easier. So absolute value of x is always a V shape. What's x squared? What shape is that? X squared is what shape? The graph. You know, you've done it like it. Looks like a U, right? X squared looks like a U. Absolute value looks like a V. Good. All right. So you've written those 2 graphs. Whiteboard's coming up. I'm going to write a whiteboard one on the bottom here so we can... So you're telling me up, down, left, or right, and how many up, down, left, or right? We're doing absolute value of x plus 4 on your whiteboard. You're telling me up, down, left, or right, and by how many? Okay? Up, down, left, or right, and how many? Up, down, left, or right? I'm surprised nobody has answered yet.
I know.
Where's it? You write it on your whiteboard. That's why you have them. Write it on your whiteboard. Up, down, left, or right, and by how many?
Got it. I got it.
That's it. Look at Eli's board. It can't be up, right, 4. It's either up or down. You're good. Yes, yes, yes. Yes. Yes, just write up 4. That's all. Like, yeah. Good, good, good. Write a little bit bigger for me, Casey. It's hard to see. I'm an old man. Yes, I'm an old man. Good. Okay, good. All you have to write is up or down, Blaze. You're making it too hard. Just up or down. Good job. Is that some Arabic too? Yes, 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 yes. Yes. Should be up 4, Benjamin. All right, look at this one. Write the equation. Write the equation. So it's absolute value of x on your whiteboard. Thank you for clarifying. Write the equation on your whiteboard. Good, 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 good. Good, 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 plus 4, good, 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 good. Now you got it. All right, good deal. So this would be y equals absolute value of x, right? That's the parent function. The only change, we're moving that up 1, 2, 3, 4. So it's just plus 4 at the end. Okay? Question? Yeah, you look at the vertex right here and determine how many up it went from 0, 0. So up 1, 2, 3, 4. That's why it's plus 4 here at the end. That's all you got to do. Easy, easy, right? Okay. So this is what it looks like on the graphing calculator. Tell me on your whiteboard, what's this one? Whiteboard. Go, go, go. On your whiteboard. Yes. Yes, yes, yes. Tell me up or down, left or right, Benjamin. Yes, yes, yes. Yes, yes, yes. Yes, yes, yes. Up how many, Benjamin? You got to tell me up, down, left or right. Tell me in words. Oh, in words. Use your words. Yes, yes, yes. Up how many? Yes. What is that? Up how many? Up how many? There you go. Yes, yes, yes. Yes, yes. Yeah, you got it. Okay, so this one would be up 2. Okay, write this one in your notes, please. Write it in your notes. Not that much harder. I mean, there's a couple more details, but it's not that much harder. So write this one in your notes. It's inside of the absolute value bars now. So if outside at the end goes up or down, what do you think this does if it's in the middle? Goes left and right. So which way does it go? Right. Why do you say right, Joseph? Yeah, but why? That's correct. You actually thought something in your head to get the correct answer. Why? Jackson? What? So if it's negative, it would go left. But think about it with the absolute value, Neva. Yes, very good. I like how Neva's thinking, right? Because the absolute value is the -5 is contained within the absolute value bars. Anything absolute value always makes the number what? Positive. So instead of -5, it's going to be +5. That's why it goes to the right. Yes. You're going to flip the sign. So if this is plus, then it's going to go where? Left or right? It's going to go left or right? It goes left if it's plus. If it's minus, it goes right. I'm going to show you on the graphing calculator here. Yep. So parent function, the absolute value of x looks like this. Okay? Yeah. Yeah, it's nice. And then if we put in from the parent function x minus 5, just so you can see what it looks like, it'll add the red one to it, and it just moves to the right. Okay? Teo? It's up or down, so if we add it like this, so the black one is going to be down to, you make it up or down, left or right by the numbers you put either inside or outside of the absolute value. Madeline? Right, let's look. So if we just switch this to a positive, I'm going to delete this one. So here's the parent function. This is the one that hasn't been changed. And now plus goes left. Okay? So when it's in the absolute value, it does the opposite of what you think. Yeah, I'm going to copy something here that you should write down. So let's get that thing. What's the function here? Y equals absolute value of x. Where's the plus? Inside or outside? Inside, plus 5. Okay? So plus 5 moves left 5. I would draw this picture Draw this picture in your notes, okay, so you have that down. Left 5. If you can cap your marker in between, you're supposed to be writing in your notes right now, Kenny. So you're drawing the graph, the red graph where it goes left 5. You're writing the equation and writing left 5, okay, just so you get all 3 ways. Because you have to go, I can give you the graph, I can have you write the equation and tell me the transformation. I can just give you a transformation, you have to write the equation. You can go any of those 3 ways, so it's good to have them all 3 down just so you can see what's up. We just went over this a second ago. When it's inside of the absolute value, you always have to switch the sign. So positive actually goes left, not right. But when it's after the absolute value, that's when it does what you think, up or down. Yep, these bars right here are absolute value bars. These things right here, absolute value bars. We'll practice this a bunch so you guys can totally get it down. You should easily be able to finish your homework in class today, which is a bonus. So tell me what this one does, up, down, left, or right on your whiteboard. On your whiteboard, up, down, left, or right. How many? Got to tell me how many. No. Yes, yes. No, yes. Yes, yes. Yes, 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 yes. Yes, yes. Yes, yes. Just left 2 and you're good. Yeah. Bigger. Yes, yes. What does that say? Left? Okay, good. Yes, yes, yes. Good, good, good. There you go. Left 2 right here. Okay, do this one on your whiteboard. Absolute value of x. The bar ends and then -3 at the end. On your whiteboard.
Oh, this is easy.
I know, write it on your whiteboard. Good. Good, 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 good. Oh, you're good. Tell me up, down, left, or right, Benjamin. Tell me up, down, left, or right. How many? Yes, 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 yes. Not right, right? Because this is after the absolute value, so that makes it go up or down. Yes, down how many, Eli? Okay, we're 3, yes. Shane, good. We good on that? Yes, yes. Okay, now you got 2 of them to write. Start with the -3 inside and then the +2 after. So you're writing 2 transformations for this. On the whiteboard, go. That's right. Zoe, good. Don't let her cheat. I just saw Catherine cheat. Yes, 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 yes. That said left, right? It should be right. Yes. Should be right. Yes. Right is sometimes wrong. Yes. Yes. Right 3. Right 3 down 2. Or up 2, I mean. Up 2. That's it. Good job, Eli. Good, good, good. Good, good, good. Anyone else? So this one, the -3 inside is what? What? Right 3. The -3 is right 3. Excellent. And the +2 at the end? What is it? +2 at the end? Up 2. Okay, you can write it just like that, in order, left to right. Okay, what do you think happens if we put a negative in front? This one for your notes. Negative in front. Amanda knows, so let's have more people think time. So what happens when you write a negative in front? Think about it. What do you think happens? You could think about like plugging a number in your head and think about what happens to that number. What do you think, Amanda? There is an imaginary 1. If that helps you, you can put the imaginary 1. Neva? Upside down. So let's look at it and see if Neva's right. So here's the parent function, and then we'll go negative absolute value of x and take a look. So parent function's in blue, the transformation's in red. Shazam, flips over the x-axis, okay? When it's negative, right, so if I plug in -1, absolute value of -1 is +1, but if I put that negative in front, then it becomes -1. So that's why every one of those answers flips over the x-axis. Yeah, fire away. Here, sometimes it's helpful, like, you can't always verbalize the question, right? It was absolute value of x, but it was negative in front. So negative. Yeah, this tiny little negative right here. So if we plug in -4, we get +4 because absolute value of -4 is +4. But if we add that negative in front, that's what switches it to a negative. So you can see all these signs switch. Every single sign switches. That's what causes it to reflect over the x-axis. So what you guys got to write for this one in your notes, this is important, this word especially, reflection. You can put a mirror on the x-axis and you'd be able to see the reflection of that absolute value function. So reflection, and all you honestly have to say is reflect x-axis. So if you say flip, I'll take a half point off. You got to use the word reflection. Okay, so reflect x-axis. Yep. Nothing would happen. If I was asking Teo's question for Joseph's question, if you have a negative inside of the absolute value, it reflects across a y-axis. Okay, so if you look at the V here, you wouldn't be able to tell, right? If the top one reflects over the y, it's going to look exactly the same. Yeah, but if we did, like here, I'll show you one of them, what it looks like. That's a good question. So let's say, you can see, we'll do -3, so that's going to make it go left 3. And then we're going to do the same one where it's -3 in here. So we have absolute value of x -3 and then negative absolute value of x. So that one moved right 3 because it was minus within the absolute value. And it just takes that and flips it upside down. So wait, let me show you though. If we, instead of have the negative there, it's kind of complicated how this works, so bear with me for a second. So now the negative's inside, and I haven't changed what's in the parentheses at all. So here's the parent where we're just moving it right 3, and this is the reflection over the y-axis. Same. It's weird, right? So, okay. Write this one. Now you have 3 transformations to write on your whiteboard. What does a negative do in front? What does this +2 do inside? And what does that +4 do? So 3 separate transformations. Write them in order, left to right. So what does a negative in front do? Write that down. Reflect. And then if you write reflect, think about which axis. 3 transformations. Reflect where? Good. It's not right. That's good. That's good. Good job. Good job. Yes. 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 It's not right. Yes. 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 The only thing that's wrong is the right. Because it's plus inside, it's always opposite. Ella. So that's reflect x. This is left or right? Left, and this is up 4. Okay. Good job, Benjamin. Yes. Reflect x-axis, and then you're good. It's a reflect x-axis. Good job. Good job. Good job. Good job. Good job. Joseph, you're good. Okay, let me write that down though. So reflect x. And then we go left 2 and up 4. Okay. So write this one in your notes, please. So we're going to talk about what happens when you have a number in front. We have a whole number in front this time, and what happens to the function. So this plus 2 makes the parent function move up 2. We've already learned that. The only thing that's different with this slope is you just think about it like a regular slope, 3 over 1. So instead of graphing where we go up 1, right 1, we're going to go up 1, 2, 3, right 1, up 1, 2, 3, right 1, and same thing on this side, right? The absolute value functions have symmetry just like the parabolas have symmetry. And then all symmetry means is you can take 1/2 and fold it over and it'll exactly match up, right? You know what makes people look really beautiful or handsome is the symmetry in their face. If you look at really beautiful people, whoever you think's like super hot, look at how even their eyes are, like even their eyebrows are the same level. Like the symmetry of the face is what makes somebody look more attractive. It's kind of weird if you think about it. Okay, so the only thing that changes is it's up 3, right 1. Okay, when you graph. What's the regular? If we have y equals absolute value of x, what's the slope on this one? What's the slope of this graph?
1.
Right? It's just 1 over 1. So you're just going up 1, right 1. And on the left side, up 1, left 1. So down 1, right 1. Yes, exactly. Okay, that's it. That's your homework. So graphing absolute value functions. Let's have a quick little recap, though. Recap. It will be. How do you know if it's up or down? What's it look like? How do you know if it's up or down? Plus or minus after it. How do you know if it's left or right? Plus or minus inside of the absolute value bars. To reflect it, you just put a negative in front of the absolute value.